let's look at how to convert a binary number to a decimal number. Now, the first thing we want to do is we want to figure out the number that's all the way to the right, and that's going to be our least significant bit. Now, this least significant bit is going to have a value that's 2 to the 0. 2 is because we're in base 2, and 0 is the position of the bit that we're in, and the least significant bit is a 0. As we go from right to left, we're going to increase until we get to our most significant bit, which is the last bit that we have. Any numbers farther out, farther to the left, are just assumed to be 0. So in this case, what we'll do is we'll say, okay, this is 2 to the 0, this is 2 to the 1, this is 2 to the 2. Notice that we're just increasing the exponent or the bit number that we have. And then we're going to have 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. Now, when you get more comfortable, you probably won't even need to do this step. I still suggest writing out the actual numbers that you have so you don't get confused and make a stupid mistake. So 2 to the 0 is actually a value of 1. 2 to the 1 has a value of 2. 2 squared has a value of 4. 2 to the third has a value of 8. 2 to the fourth has a value of 16. 2 to the fifth has a value of 32, 2 to the sixth has a value of 64, and 2 to the seventh has a value of 128. All I did was evaluate this exponential number that we have. The next step is we're going to take that number, so we're going to take this row, and we're going to multiply it by the corresponding bit in this row. So what we have is this is 128 times 1, plus 64 times 0 plus 32 times 1 plus 16 times 1. We're just taking whatever value we have and multiplying it by the corresponding bit, plus 8 times 0 plus 4 times 1 plus 2 times 1 plus 1 times 1. And if we simplify that right away, we see that anything with a 0 just goes away. And we have 128 plus 32 plus 16 plus 4 plus 2 plus 1. Now, if we add up all of these numbers, we get this is 3, 7, 23, 55, 183. So this binary value is 183 as a decimal base or base 10. Now, when you're more comfortable with this, we're going to look at the second example. You can do this a bit faster. Now, I still always recommend writing these numbers out just so you don't forget value accidentally. But all you have to do is, if you notice, if you have a 0, you just can skip it. And if you have a 1, you're just having a 1 multiplied by whatever number this is. So this is 128 times 1 is just 128, plus 64 times 1 is just 64, plus 32, this is a 0, this is a 0, plus a 4, plus a 0, plus a 1. So what do we get here? We get this is 537, 101. This is equal to 229 in base 10. Hopefully this helps you with converting from binary numbers to a decimal number.